Hello.
Hi, Professor.
Hello, Chris. Hello, Kirsten. Hello.
Hi.
Thank you for the hello. Hello, Brian. And also, hello, Alicia. I totally get it. I totally appreciate it. I totally note it.
Hi, Professor.
Hello, Miriam. Hello, everybody. I'm excited to see everybody. And yes, okay. Sorry. And I'm so excited. I don't even know what to do with myself. But yes, I totally get there's certain people here who are totally following instructions from this morning. Thank you. Okay. Hello. Yes. Hello, Gianna. Hello, Kirsten. Hello, Abdel Rahman. Hello, Jasmine. Hello. Hello, Alejandro. Hello, Tobias. And then also now I go to hi, Miriam. Hello, Brian. Hi, Gianna. Hello, Kevin. Hi, Alicia. I seriously, I get it. Thank you. That's awesome. Good afternoon, Tobias. Hey, and good afternoon. I got double greetings. Alejandro. Hello, Felicia. Hey, Sumaya. Hi, Jasmine. Hi, Sarah. Sorry. Oh yeah, it is yes. Good afternoon, Abdel Rahman. On this beautiful day, it is a beautiful day to be inside on Zoom. Absolutely, a beautiful day to do physics. Absolutely. Okay. No, it is good to see you all. Okay, wait, I'm going to change the view. Okay, I want to go to the second sheet today, but I know, excuse me, I know that in this class, all of a sudden I got all flustered at the surprise, at the end of the last class, and all of a sudden everything fell apart, and I made this mistake, and then got all confusing, and it was all happening right at the end of the class, so there was no way anybody could really calmly pay attention or get it. So I just want to, before we go to, we're going to go to the second sheet today, but before we do, please forgive me, I'm going to back up a little bit and just make sure that we're clear on the last two questions of homework 1. In fact, I might even do, well, yes. So this might already be clear in your mind, but just in case there's any confusion or frustration or any mistakes in your notes, what I'm going to do right now, I'm going back to the old notes from 2 days ago. In fact, yeah, so I'm going to back up a little bit, and just because I see where the error came from. It came from the fact that I was interrupted, then I'm about to be interrupted again, but okay. If you go to question 6 on the sheet from homework 1, and forgive me, we're about to be interrupted temporarily, but if you go, to homework 1, question, actually, let's say even question 5. Now, you're going to have to either look at your own sheet or look at the diagram or picture the diagram. Oh, someone's here. Sorry. I mean, someone's in the class. Hold on. Sorry. Okay. If you oh, okay. Oh, okay. Thank you for the direct message. Totally got it. Thank you. And hello. Got it. Okay. If you remember the situation, the diagram from the beginning, like the professor, the instructor in the problem starts at this. Oh, okay. I'm just looking at the private chat again. Hold on a second. Sorry. Oh, okay. Thank you, private chat. I got you. Thank you. I got it. Okay. I appreciate it. All right. So again, homework 1, situation. The instructor starts at position 4. He goes all the way to position -2. Then he comes back to position 4, right? And then in the final stage, in the last 3 seconds, he goes all the way to position -5, right? So, and we're calling the left-hand direction negative, and we're calling the right-hand direction positive. So in the last 3 seconds of the whole thing, in the last 3 seconds of this entire affair, the instructor is moving to the God, a lot of people are joining. Okay, he's moving to the left, going all the way from position +4 all the way to position -5. Right. So just hope either you're looking at that on a sheet of paper or you're picturing that in your mind. So then question 5, like where the answer is right here on the board. Question 5 asks, what's his average speed for that interval? And average speed is defined to be distance over time, like, right? And remember, please remember for this stage, hello.
I need this
Oh, thank you. It's not mine and not mine. You can ask, I mean, it's not.
So
fun
it's all
stuff.
for yours?
No, it is all for mom, actually.
Oh yeah, that's what I meant.
Okay.
Mom, this is all for you.
Okay. So remember here in the notes that you're looking at right here on the screen and that you got in the Google Classroom, these are just answers, not solutions, right? If I were to do step 3, GDP, general definitions and principles, I'd first write average speed, triple equal sign, distance over time, but I didn't here. I'm just putting the answers. But so distance, the distance that he travels when he's going to the left, the distance is 9 feet. Just positive 9 feet, right? So the distance is 9. The average speed is not. Good afternoon. Good to see you. Excellent. And good to see you on the jaywalk the other day. Or good to be seen by you on the jaywalk. Okay. So the average speed is positive 9 over positive 3. That's an average speed of 3 feet per second, right? Again, I'm backing up for anybody I'm going back to question 5 from the sheet. So question 5 said, what's his average speed? But then now, question 6 is actually slightly more interesting than I think I gave it credit for when it went over yesterday. Question 6 now asks for the average velocity. So average velocity, triple equal sign, is displacement over time. So displacement actually does take into account direction. The fact that he's going to the left or that he's going toward the negatives means his positions are getting smaller and smaller. His displacement actually negative. So the displacement's -9, the time is 3. So his average velocity is -3. Just pause for a second. Now, again, believe me, I know a lot of people in the class already knew that. They already got it right, or they knew it yesterday. Like, I'm not saying this is a big, but I do want to note for some people in the class, just note velocities can be negative. And when your velocity is negative, it doesn't mean you're slowing down. I think that's part of what I want to emphasize right here. Velocity negative just means you're going in a particular direction, right? It's like just a shorthand for saying, no problem, thank you. And your friend had your back. When someone says that their velocity is negative, that's just like saying they're moving south or something, right? Don't let the negative sign throw you off. Okay, so anyway, this guy's speed is 3 feet per second on average, but his average velocity is -3 feet per second because he's going that way. So what I'm trying to admit to everybody is, I think when I was flying through class at the end yesterday, and this may have also happened in the other section, hint, hint, I may have just written that as +3. I don't think I realized they were asking about the last 3 seconds. So it's -3 for the velocity because he's going left. Now, why does that matter? Because then when you get to the last 2 questions, the questions where you have to think, right? And you do have to think. Now, these questions now ask things where you have to break. Now you really have to start dividing your thought process into steps. I mean, this is really where the 5-step process comes in. Again, I know the bulk of you got this right, probably, but a number of you very legitimately started getting stuck around this part of the sheet and started saying you didn't know what to do or something. And I'm trying to encourage, don't be fooled by your own intelligence. Don't think that just because you can't see the light at the end of the tunnel right at the beginning of the tunnel, then that means you don't know how to navigate the tunnel. Like, sometimes we have to take one step at a time in the dark until we get to the light. Like, seriously, in fact, usually in physics, right? So it's really good to have a method for what to do when you don't think you know what to do. Generally, when people say they don't know what to do, what they really mean is they don't see how it's all going to end up, so they don't even want to start. But if we do, in this last question, or in the second to last question, when it asks, where does he end up at t=7, at the middle part of that last journey, or 2 seconds into that last bit of the journey, what I'm saying here now is, for that last bit, I'm just focusing my concern on just this last section of the experiment for this and I'm treating it like it's its own experiment. For this last section, the average velocity is -3. Again, if you happen to be in the other section, I think I might have said this wrong in the other section. Just please make a note in your notes and correct this. The velocity is -3. I'm making a note of that. And now I'm doing a little GDP thing here. I'm saying if average, I rearranged the equation. I guess I did talk a lot about this yesterday, but I rearranged the equation, which is not only legal, but it's expected as something you would do from now on. I multiplied both sides by t. Then I added x0 to both sides. So I'm saying final position equals average velocity times time plus initial position. So, and so here's where the correction is. So the average Right. Okay. So and I'm going to look in the chat in a second. I think most of the people in the chat are saying hello, but I'll look in the chat in a second. But I'm saying now, and this is the part I want to be, I wish it weren't squished at the bottom of the page, but, oh, can you not hear me? I'm sorry. Wait, can you not hear? Hold on. If I,
Hear
Oh,
you.
now I can, Professor.
oh, wait, you can't. Okay. Sorry. Wait, sorry, you can, okay, I'm gonna keep, here, I'll fix the input. Wait a minute. I'm sorry. This happened the other day too. I don't know why. Hold on. Yeah, the input always, hopefully this is a little bit better. I just put the input up a lot. Hopefully this is better. Could anybody, you can hear me? Wait. You can hear me. Okay.
Yes, we can hear you.
Okay, thank you. Sorry. Okay, so so the last thing I'm just trying to say is the average velocity is -3. The time is 2 seconds. Okay, let me be slow about this now too. Why am I saying 2 seconds? Where did I get 2 from? Because I'm just looking at the last segment of this whole experiment. I'm like resetting my clock in my mind. I'm pretending that I just started looking right at t equals 5, right when the instructor began that last bit of the journey when he's going all the way to the left from position +4 all the way to position -5. This is actually kind of an important detail. Again, you might have gotten this right or something, or all of what I'm saying right now might be like, yeah, can you please? But I really want to emphasize when we say t, we mean t from whenever we start paying attention. So for this, and as long as you're consistent with all the other things. So for example, if I want to use V bar as -3, if I want to use that fact that the average velocity seems to be -3, that's only true for this last segment of the experiment. So my clock started at the beginning of this last bit of the experiment. My clock started at what we otherwise we're calling t equals 5. It started when he was back at the 4 meter mark. So my x0 is 4, my t is 2. because we're ultimately asking where does he get to by what we used to call t equals 7, right? And my v is -3. I'll say this one last time. I'm saying that what t equals 0 is up to you, but then you put in all the other facts into the equation that are consistent with that. All that, you're always picturing a certain interval of time and space and putting in all the facts consistent to that interval of time and space. Okay, so I wrote x equals -3 times 2 plus 4. So then I plugged it. Oh, this is all okay. So then here it is, -3 times. So I'm middle of the page right here, -3 times 2 plus 4. So you get -6 plus 4, and the answer is -2. In other words, where he ends up at t equals 7, or what I'm now thinking of it as 2 seconds into the last bit of the whole journey, where he ends up is at the -2 mark. What I'm really saying in English, and then I'll move on, but I feel bad that I got spazzy yesterday, and I just want to make this as clear as possible before we move on. What I'm just saying, okay, I'm saying two things. One, I'm saying from now on, even though we only have one equation right now, that equation really is at least 3 equations built into one. It is assumed or expected that you could just do the algebra to rearrange that equation at will at any time. So sometimes questions will involve a couple of steps like that. Like they'll get more and more involved as we go. Please be prepared for that. But number 2, I'm also saying this rearranged version of the equation, like don't memorize it or anything like that. Don't memorize it as a new formula. Just understand. Sorry. Oh, thank you. Okay, sorry. Got it. Sorry. Yes. This is not a new equation. It's the old equation. But I think this new arrangement of it does make sense in English if you just step back and picture. And again, of course, if you're looking at the diagram while I'm talking, it's pretty helpful. I'm just saying, really, the guy is standing there. So to back all the way up for this last bit, and then we're done. The guy is standing there at position. The guy is standing there at position +4. And we want to know 2 seconds later where he's going to be, because this is all at t equals 5. We want to know what's going on at t equals 7. So he's standing there at position +4. We want to know 2 seconds later where he's going to be. Well, we know that every second he retreats backwards by 3 feet. We know every second he's going backwards. He's going to the left 3 feet. Why do we know that? Because we know that in a total of 3 seconds, he's going to go all the way back 9 feet. So if he's going at a constant rate, then every 1 second, he's going backwards 3 feet. So in 2 seconds, he goes back a total of 1, 2, 3, 1, 2, 3 again, a total of 6 feet. He goes back 6 feet from the +4 mark. So he ends up at the -2 mark. That's all what I'm trying to say. And so then the very final question, when it asks, what's his average velocity from the very last question is, what's his average velocity from the interval t equals 3 through t equals 7? That means we want to know what total displacement did he cover from t equals 3 to t equals 7. And the thing is, at t equals 3, he was right there at that mark, at the -2 mark, because it tells us that in the problem. And at t equals 7, we just figured out he was at that same place, the -2 mark. So he got nowhere during that time. So it was a round trip. He ended up where he started. So his average velocity for that intermediary 4-second chunk was 0 feet per second. Okay, so that's the end of homework 1. It took us a while to get there, but that's the end of homework 1. We're going to move to homework 2 now. The other takeaway from all that, perhaps, it's just practice and all of that, but the other takeaway is, notice that when we ask what's the average speed, or we ask what's the average velocity for something, well, the answer totally depends on what interval we're looking at. Like the average could be one thing for the whole entire experiment, but it's going to be a different number for different chunks of the experiment. Just bear that in mind. Okay, so we're going to move on now. Sorry, that took slow. We're going to move on to average speed. So I'm going to switch some things in the, bear with me. But again, obviously, if you have a question, please put it in the chat. Hold on, switching. I hope you're still all with me. Yes, I'm bored too. Okay. I mean, I'm not. I'm excited to be here, but I'm bored by myself. So I'm going to switch. Okay, so now we're going to talk about average speed. Okay, so mostly today we're going to go to we're going to the next homework sheet, homework 2, which you didn't get back yet, and I'm totally aware of that, and I'm apologetic. So if this helps you, good. We're going to go to average speed. Now notice again, there's average speed and there's average velocity. Average velocity is a more involved concept. It involves direction. It's a vector concept. But even average speed itself can have some nuances and some tricky things to think about that homework 2 is trying to get at. So now what I'm going to do is just sort of in the spirit of what I did at the end of Monday to start making a little more tracks and to start moving a little bit faster. The first few of these questions, I'm just going to give you the answers to, because I have a sense that a lot of you probably, or actually I know a lot of you probably did them right. So I'm just going to give you answers to the first, and then I'm going to get to the issues of, so in other words, on these warm-ups, I'm just going to write down the answers. Please stop me if you do have any questions about these answers. And please notice, these are not full solutions that I'm writing down. You would have to give a full solution, but I'm writing the answers thinking that you probably got them right, or many of you did. But if you didn't, there's no harm, no foul. Please stop me and ask question. But so warm-ups, I'll just read out loud. And again, if you have your sheet in front of you, that would help a lot. It's hard for me to do the screen share back and forth between two things. But okay, so we have so in warm-up 1, a new car travels a total of 60 miles. The trip takes 2 hours. What's the car's average speed for the trip? Well, average speed is defined to be total distance over total time. So the total distance is 60 miles. The total time is 2 hours. Absolute. This is not meant to be a trick. That's the answer. It's 30 miles an hour. It's not meant to be a trick, but one thing. Oh no, there's nothing. Okay, that's it. That's the answer to that. Look, it seems like you don't know questions, but all right. Then B, not meant to be a trick, but just meant to show you something like this whole concept of average speed is total distance over total time. It's a definition. It's so strictly, rigidly always true that even if there's weirdness going on, even if cars stop or start, or even if there's zeros, they get included in the average. So in other words, I mean, even if there's break, because this question says an old car travels a total of 40 yards, the trip takes 4 days and includes 3 breakdowns. The point is, do the breakdowns matter? No, they don't change the calculation. They just make the whole number much smaller. So the answer for this one for number 2 is 40 yards divided by 4 days. So it's 10 yards per day, which is very small. It's an old car, whatever, but that's the answer. Okay, all right, so that's it. Then C, C, also not meant to be a trick, but just meant to say again, all right, we should be able to rearrange these things in our head. Like this time, it's giving you the average speed, it's giving you the time, and you have to solve for the distance. So you just rearrange like we did before. So distance will equal average speed times time. You may have heard something like that before in your life. And for whatever it's worth, these facts that are being given here, you may or may not know, they're actually true, realistic fact. Like it is true that light does travel 186,000 miles every second. It travels the equivalent of, wait, someone's here, sorry. So that means, for what it's worth, that light travels the equivalent of 7 full Earth circumferences in a second, just for perspective. This is true. Like, I'm not saying light travels in a curve, but I'm saying that if you were to imagine the entire circumference of Earth, like unwrapped and be a straight line distance, like 7 of those circumferences is what light does in 1 second. Put another way, it can go, I mean, right, that's pretty astoundingly fast. that means it can go the distance of it can go from here all the way back to here if it traveled in a curve like that in 1/7 of a second. That means, and so that means the farthest anywhere it would ever have to go on Earth, what that really means is the farthest light would ever have to go on Earth, like the farthest point you can imagine somewhere else on Earth's surface, like so far, like the farthest you can imagine is like halfway around the circumference, right? Because anything farther than halfway, then you could just go the other way and it'd be closer, if that makes any sense. So like what I'm really saying is here, pick the point on the Earth that you think is literally the farthest from where we are now. I mean, Beijing or Nanjing or something like that, right? Like for light to get there, it literally only takes a 14th of a second. Like that's cray cray. I mean, that's, anyway, I don't know. That's just, but it's true. So, so in 1,000 seconds, just for practice, light would travel 186 million miles, or in other words, in scientific notation, if you want to put 1.86 times 10 to the 8th miles. I mean, that light is fast, just say. Okay, so that's the answer to that one. There's not much. Oh, thank you. Okay, awesome. Thank you, Abdel. That's totally class participation. That totally counts. All right. So all right, those are just warm-ups. Those are exercises. Hopefully you got them right. Or if you have questions, please let me know, or you can privately let me know. There's no shame. But now I want to get to what is maybe a little bit more of an issue, which is the next question in the sheet, the question 2. I think I'm just making sure I have it. Yeah. So Hill figure now. All right. I think I might have even mentioned this in class yesterday, or maybe actually that was the other section. So we're now going to go to 2. Whoa, hello, what just happened? Okay. Now, this problem, I don't care who you are. You know how I'm always defensive and I'm always saying, oh God, sorry, this is taking so long. Oh God, this is so boring. Oh, no one of you. I mean, I'm always saying that, right? I'm not saying that about this problem. This problem is worth thinking about, even if you got it right. I mean, maybe especially if you got it right. Definitely going to say from the start, if you got this problem wrong, there's no shame. Don't be angry at yourself, but also please don't be angry at me. This problem is tricky. It is not a trick question. Like it's not a trick. It's a problem that is meant to reveal the trickiness of average speed. Okay. And if you didn't get it at all, no shame, but hopefully you did some work and got somewhere from here on. And if you ever, the only time to ever have like shame is if you just completely leave a blank space. Let's try not to do that in the future. But so, all right, what was the deal with this problem? So I'm going to try to do the step method sort of for this now. So the problem here is the situation is something like this. Right? Okay, this is like a weird drawing, but I'm just trying to say this car goes up a hill at an average speed. I'm putting those double absolute value signs around it just to say that it's speed, not like I'm not even worrying about direction. The average speed on the way up is 40 meters, 40, sorry, is it, it's sorry, is it miles per hour? It's not, sorry. Oh, it is. Okay. So he goes up at 40 miles per hour. Then he comes down the exact same hill at 60 miles per hour. So we know, oh, and the question is, Okay, just side note, from now on in this class, if I ever, because I want to start getting more and more to equations, right? This problem is not asking about velocities, it's only asking about speeds, but I want to kind of be mathy about it. So from now on, if I ever have something that I think is a vector quantity, like velocity is a vector quantity, if I put double absolute value symbols around it, double absolute value symbols, that means the magnitude of that vector, the size of that vector. Speed is the magnitude of the velocity vector. Okay, so I mean, and they're double abs. I'll explain later why they're double absolute values, but it's like absolute value, but it means magnitude of a vector. All right, so our ultimate goal in this problem is to figure out the speed, the average speed for the entire round trip. We're given the average speed for up, we're given the average speed for down. We want the average speed for the entire round trip. All the facts that we're given are here on the page. The question that we're given is here on the page. So in other words, I have my step, I'll say this. So I've done step 1. Diagram and fact pattern, right? And over here is step 2. What is the question? Right. So now I'm going to get to 3 GDP, but these are all the facts. Now notice on the one hand, what we have is a hill. He goes up a hill and he comes down the same hill. I think it's actually it's very important information that it's the same hill. What I know is that whatever distance he went up is the distance that he or she, or I guess it's he, went down. That's important information, that the distance up is the same as the distance down. However, what you also might notice is whatever that distance is, I don't know it. The problem did not give me the distance of the hill. That's a little bit noteworthy. Okay. Now, I'm talking a lot of making a big deal of this problem. I don't remember if I mentioned yesterday or that you might be thinking, why is he talking so much about this? Like, I mean, my God, like 40, 60, he up, down, he wants the average. Isn't the average 50? Now, I definitely don't want to single anybody out. And I definitely don't want to single anybody out. I want to tell you that the answer to this question is not 50. If you think it's 50, you should not be ashamed of yourself at all. If you think it's 50, what you should be thinking is, oh, good, I guess I'm going to get some worth for my money for this class. Like, I'm going to learn something, I guess. Like, it's expected that you might think it's 50. I totally understand that you might think it's 50, but it actually isn't 50. And that's what I have to talk about here. Okay. I have to get the average speed for the round trip. Well, actually, I'm going to pause. Well, yeah, let me make this clear. Why anybody might think it's 50 is because they might average those two numbers, 40 and 60. They might add 40 plus 60, get 100, divide by 2, and get 50. In other words, 50 is the number directly in the middle between 40 and 60. All of that is true. 50 is definitely the average number between the two numbers, 50 and 60, 40 and 60. But 50 is not the average speed here. And the first reason I want to say why it's not, and again, this is not supposed to be a trick. It's not supposed to make you feel stupid. It's meant to point something out. But the reason 50 is not the average speed here is the first reason is no one ever said in this class that average speed is defined to be average of speeds. What we said is that the definition of average speed is total distance over total time. That is true of average speed and will always be true of average speed. That's what we know about average speed. It's total distance over total time. So in fact, I'm going to say that. Wait. And what that has to do with averaging numbers, I don't know offhand. So I'm going to say, so what I'm really trying to say in English here is I've done step 1 and step 2 of the process of the problem solving process. Here's step 3, GDP. I'm supposed to write down something that is generally true, a principle or a law or a definition. I'm supposed to write down something here that is true, that certainly might be relevant to this problem, but that's true even before the problem began. And what we know, so the problem is asking us to find average speed for a whole round trip. So I'm writing down the definition of what it would mean to be average speed for a whole round trip. It would be total distance for a whole round trip over total time for a whole round trip. That's what average speed would be. Like up plus down, in other words. Now, maybe you think that number should be 50, and maybe it will be. We'll find out. But what I really want to tell everybody is, and again, part of me really wants to, here's the thing. While I'm talking, I'd be interested, you don't have to do this, but for participation points, whatever, if in the private chat, tell me what answer you got for like in the private chat. Please tell me what answer you got for this question, if you got an answer at all. And let me remind you before you, and I want you to be honest, okay? I want to know, oh, cool, thank you. And let me remind you even, so one person's being honest already, thank you. Let me even remind you, and don't like, I want to remind you that there's portals for participation that exist. First of all, for writing down anything that could be right or wrong. There's one portal where you write down any answer at all that I could call right or wrong, and you get points for that. But there's a specific portal even for, I think it's open, for if you actually say something that turned out to be wrong, you get points for that. So please don't be afraid to be wrong. I just kind of want to know who, because like if everybody in the room got it right and got it right for the right reasons, then maybe I don't want to, bore you for an hour. So I would like to know if I'll actually feel it'll help me if everybody admits to me what answer they got for this. And if you got it right, that's great too. But please tell me in the private chat what you got. Oh, wow. Oh, wait. Oh, sorry. Okay, wait, no, I totally appreciate the answer. I'm getting a lot of honest answers in here. I appreciate. One person's even telling me that, I'm not going to read names out or anything. Wait, so one person's asking me, I'm not up to the grandma house problem yet. This is still the uphill, downhill problem. The grandma house is next and is very similar to this. Once we understand this, we could probably do that one, but I'm talking about the uphill, downhill one. Okay, and I'm seeing, okay, and so some people did get it right, which is awesome. And some people are even saying that they watched a previous lecture. That's awesome. And by the way, I think there's a portal for that too, for using the YouTube channel in any way, which could mean subscribing, but you certainly don't have to subscribe. But I think if I haven't opened it yet, there's a portal if you ever use the YouTube channel as a resource at all, just so I know you get, that's great that someone's admitting that. And and this is good. Really, I hope you guys understand. Telling me anything in the private chat helps me teach. Like if all of you said the wrong answer, then I would really know what I need to explain. And if all of you say the right answer, then I'm going to do something like, it's not about criticizing you. This is not a test. I just need the feedback. But okay, I'm seeing. So please feel free to put in the chat what, and if you didn't do it at all, by the way, you could put that in the chat too. It won't change your homework grade, but I just need to know who I'm talking to and how to talk to them. But okay, so I'm seeing some things in the chat. Cool. Thank you. Again, keep it coming in the private chat. What happened? But okay, so some, and if you want, any of you, well, all right, I'm going to say, because I'm seeing some of the answers, like I'm going to say right now, first of all, I don't have a reason to believe, I don't think the answer is 50. I'm even going to tell you why it's not 50. Oh, wait, hold on. Oh, okay. Oh, that's very honest. Okay, and someone's saying that they went in a roundabout way, that you're not sure it abides by your 5-step method. We'll see. It probably, if it was long, you might have gone in a different order, but I bet it does fit my 5-step method if it was, but we'll find out. Okay, but I appreciate the honesty. But what I really want to tell people is, again, for some people might still be at the, all right, I'm just going to teach. Like here, I think this is the first problem where for many people, not necessarily all the people in the room, but for many of you, the 5-step method might really start really helping now, partly because it might help you see an answer that you didn't already see. Like this is the first problem, I think, for many of us, where even if you did get it right, or even if you do see the answer, I don't think the answer is immediately seeable. Like for many of, I mean, well, the wrong answer is, but for many of us, even if I'm saying here now the answer is not 50, that does not mean you can look and go, oh, I see, duh, obviously the answer is 57. Like I wouldn't. Like I know the answer, but that's because I literally had to think it through. So partly what I'm going to advocate right now is that the 5-step method can actually help you get somewhere that you didn't see initially. But also, let me also remind all of you that even if you go awry, the 5-step method is a way of getting lots of points, even if you don't know what you're doing. Okay, so I'm going to say this. And one of the reasons that step 3 is general definitions and principles is really there to remind you got to write down things first that are true and then apply them to the problem. Don't make up something. Like if any of us who got 50, if you're not being crazy and you're not being stupid at all, and you're using something that seems right from another class, but here you are making something up. If you say average speed is the average of the two speeds, like that's not it's not a definition of anything. All right, so anyway, okay, so what am I going to do? What am I going to do? By the way, I'm going to get back to the point. I'm going to do this probably in 2 different ways. One way that I think maybe some of you would do, and then a way that's maybe a little bit faster. But any way you do it, if it's right, it's right. So I'm going to say, okay, I did step 3. I need the total distance over the total time. Okay, so I'm going to start filling in. So I'm going to say, all right, total distance is distance up plus distance down, right? That's what I need in the top. And total time means time up plus time down, right? Now, and that's true, right? I'm still saying things that are true. They haven't used the numbers of the problem. They're just true. Now I'm going to start having to deal. Now I'm going to have to start dealing with the particularities of the problem. PAW step 4. Oops, sorry. So I want to start now plugging in numbers or something. And this is where maybe many of us get stuck, because now I say, wait a minute. I say on the one hand, the good news is distance down, whatever it is, equals distance up. But the problem is I don't know the distance up. Like that's what the problem didn't give me. And I even think that I could know what the time up is if I knew the distance up, but I don't know the distance up. In other words, all the facts I need, I seem to not know. That's what makes this problem difficult. It's not an accident. It's not a trick. It's just difficult. All the facts that I seem to think that I need, I don't seem to have. Now I'm dwelling on, and that's true. Okay, that is true. I'm going to tell you what to do about that. But first reason I'm dwelling on this when we're all together, here's, I want you to realize that if you do this step method, then you get to this point and realize this. It's an important thing to realize, and it'll help us do the next thing. But see, if you don't do the step method, so what makes this problem hard is that we seem to be missing key information. But the thing is, if you jump at a problem and you don't break it up into steps, what I think a lot of us did, the reason a lot of us made up a definition, the reason a lot of us just decided to average the 2 numbers is our brain worked so fast. We're so much smarter than we actually think we are that we end up thinking we're stupider than we are, because our brain went so fast that what our brain did is it probably went, okay, average speed equals distance over time. That's what Yavram keeps talking about. Average speed equals distance over time. And then our brain went, oh crap, I don't have the distance. So then our brain went, oh, well, that can't be right. I don't have the distance, so I can't use that equation. So that can't be right. So I'll make up a new equation. And then we just made up a new thing and we average things out. In other words, we made something up because we felt we were missing information. but we did it so fast that we probably didn't realize that the issue is that we're missing information. And the answer to being missing information is not making up some new general truth. The answer is to deal with that information. So what I'm saying is, we want the trick to physics really is one of the ways to know what to do when you don't know what to do is to know very explicitly what you don't know, is to confront the thing that you don't know. The issue here is that we don't know how big the hill is. It's such an issue that what I think is that it tripped up a lot of people before they even realized that that's what was tripping them up, that we don't know how big the hill is. And by the way, it's not a mistake in the problem. It's just what's challenging about the problem. So what can we do? We say to ourselves, well, I would know what to do if I knew how big the hill was. Like my problem is my problem is not the physics procedure. I know I'm supposed to plug in distance to the numerator and plug in time into the denominator. I know what I would do if only I had this information, but I don't have the information, so I can't do it. We say to ourselves, oh, wait, yes, I can. I can just do that. Let me see what would happen if I did have the information. Let me put something in the information's place and let me carry through the process and see what will happen, because maybe that will reveal an answer. In other words, like I'm saying, to be really blunt, wait, I'm looking at the time. Say this is an exam. Okay, say this is an exam and you're trying to get the right answer to this. The problem, because we're missing this one little thing, what happens is, and if we don't do a step process and we're not calm, because we're missing this one little thing, people collapse and either do nothing or they make up some whole new definition and go completely down a wrong road. I'm saying, whoa, whoa, whoa. If we know exactly what we're missing, why don't we do everything but that? In other words, if you're trying to clean your room and there's like a really annoying pile in the corner of your room, don't let that stop you from cleaning your room. Clean all the rest of the room around that pile. And by the time you've cleaned all the rest of your room, it'll actually be a lot easier to deal with that little pile. Like you'll be encouraged to just remove it, right? But it's hard to remove, right? So let's do that. In other words, let's put a placeholder in for that missing, that hill information. Let's let Now, this is approach number one, by the way. I'm going to give you a more elegant approach by this than this when I'm done. But I really want to emphasize to you, like, this is not an algorithm. This is not a formula. This is an approach. This is called being scientific. This is called experimentation. Like, we have to figure something out. The way to figure something out is to put things in places, work around them, then remove those things. Like we have to make our own path, especially if we're going to grow up and do scientific research. That's what it's about, making our own path. And especially if this were an exam, we want to do something. Like, in one way, I'm trying to teach you the most intellectual thing of all, the art of the science. In another way, I'm just saying, if this were an exam, you want to get as many points as you can. You don't want to, right? So just do everything that you can, except for the thing that you can't. So what am I really saying here? What am I really saying? And again, I'll be more elegant about it when we're done. What I'm really saying here is, in the background, I'm saying the problem didn't give a size of the hill. we think that's really bad and problematic that we didn't get a size of the hill. But if we really think about the way science works, if we really think about the way science works is, if the problem didn't have a mistake, if it's an actual real solvable problem, and it asks for an answer without giving a size of the hill, if you really think about it, doesn't that mean that the answer must not depend on the size of the hill? Right? I mean, if this is a legitimate problem, if it's not a cheat or a trick, it actually probably is the case that whatever the answer to this question is will be the answer, no matter how big the hill is, because apparently the hill size does not drive the problem. So apparently I can say, let me try that the hill size is 1 mile long or 2 mile long, or better, since I can do that, since I'm just going to try a number and see what happens. It's not guaranteed, but I'm going to see what I would do with the numbers. Since I can pick any number I want, I might as well pick a number that's actually easy to work with. Since I'm just picking one anyway, I'm going to say, now this one person said they went about it in maybe a roundabout way. Maybe this is the way they did it, or maybe this strikes them as more roundabout than what they did. We'll see in a minute. And again, by the way, and just roll with me here for a minute. I'm going to give you a more elegant method when we're done. But what I'm really trying to show everybody, especially since some people, thankfully, were very honest enough in the chat to say they got it wrong. Well, I'm not just trying to give you a right answer. What I'm really trying to show you, sort of always in this class, is like what you would do. Imagine this is an exam and this question comes up. And you studied and all of that, but it's not like biology, and I'm not trying to insult biology, but it's not like a thing of as long as you studied, then you know the problem and then you just do it. Like there's always a new problem in physics that you have to figure out for the first time. So what I'm really trying to do is show you, what do you do when you don't know what to do, right? So what we're doing is we're saying, okay, the one problem is I don't have a hill size. So for the moment, I'm going to make up a number for that hill size. I'm going to make up a number. I'm not saying it's right. And I don't know what's going to happen, but I'm going to make up a number so that I can work all around that number. And if nothing else, at the end, when I get an answer, maybe my answer is only based on that number, and maybe that number was wrong. But then Yaverbaum is only going to take off points for that number, and everything else will be right. Like, right, we're just trying to minimize our error, reduce our error. But also in the back of my mind, what I'm really saying is, you know what? If I can just try a number and see what happens, the chances are actually I'll probably see something that's going on and see actually how to get the right answer. Maybe my answer will be right for whatever number I pick, because apparently the number doesn't matter anyway. So if you're going to do that, once you say to yourself, I'm going to pick a number, which I'm saying is totally, by the way, I'm saying totally okay on an exam. In fact, really admirable to pick a number and then work with it. Then if you're doing that, a definite physics strategy is pick a number that is easy to work with. Like, why not? Why give yourself a headache? So I'm picking the number 240. You could pick the number 120. You could pick the number 480. I'm picking it. You could pick the number 4,800. I'm picking a number that's evenly divisible by 60 and 40 to make my life easy. Okay. And I'm going to see what happens. And I'm watching the clock. I'm going to use this number now. Now, again, I'm talking a lot about this because I think we're now getting into physics. We're now getting into the art of the science. Some of you who are listening to me might be thinking, wait, he's making crap up. He's just like, he's just making up the hill size. How is that scientific? And I'm here to tell you, first of all, oh, it is scientific. It's called experimentation. It's called hypothesis. It's called conjecture. I'm not guaranteeing this is right. I'm making up something to work with to see if I can progress. That's number one. But number two, what I'm really saying, and I say this with all due fondness and respect, is if you don't do what I'm doing, what many of you did is you secretly made up an equation. You just maybe didn't realize that. But I'm just making up a number for the moment that I'm going to toss out when I'm done if necessary. But it's better to do that. I mean, if you're willing to make up a whole definition, what's wrong with making up all right, you get my point. So I made up, and again, there will be a more elegant way to do this when you're done. I'm not saying you all did this, but provisionally, I'm hypothesizing that the hill size is 240. So I could see what I would do then. If I hypothesize that the hill size is 240, then, and this is all still under step 4, PAW, then average speed for the total round trip would be 240 miles up plus 240 miles down, right? So now I got something to work with. I've got the up distance and the down distance. Now I need the time up plus the time down. So then you might say, oh, well, do we know those? Well, yeah, we do now, right? We know speed equals distance over time. Like, we know, I should be using letters now, but here, oh, sorry. Hold on 1 second. We know that the average speed up equals the distance up divided by the time up. And so then we know, therefore, if we multiply both, we know, therefore, that distance up equals and therefore we know and again, I'm sorry I keep putting the double absolute. Don't be intimidated by those double absolute values. I'm just putting them every time just to say that I'm saying speed, not velocity. Just bear that in mind. But now look what I just did. Now I'm doing like what I did in homework 1. I'm taking the equation, the only equation we have so far, the only definition, average speed equals distance over time. And I'm just cross multiplying twice, or I'm rearranging it twice. So I could say time up equals distance up over average speed up, right? Like that's just true. If the equation is true, that's just true. And I'm intentionally rearranging it to, I'm not saying that's a third equation. I'm not saying now memorize this or put it in a formula sheet. I'm saying it's just true if the original equation is true. So then the distance up, according to this hypothesis, is 240 miles. And the average speed up, we said, was 40 miles per hour, right? So the time up is 6. So the miles cross out. I mean, the miles cancel out. Can't make this clear. Sorry. So it's miles over miles per hour. That's a little confusing to some people, but it's miles over miles per hour. So the miles cancel out, and then it's 1 over hours. So, when you divide by a fraction, you multiply by the reciprocal. So the hours flip up as they should, and you get that the time up is 6 hours. Now, maybe a lot of you might have done that in your head or could do that in your head if you thought to do it, right? I'm just saying, if the hill was to, hypothesis, if they assume that the hill is 240 miles up, then when we're going up at 40 miles an hour, because that was a given in the problem, it would take us 6 hours to go up the hill, right? Now, I'm not saying that's an answer to anything, but I'm just saying if the hill is 240 miles high, then it took us 6 hours to go up the hill. Similarly, by the exact same logic, to go down the hill would be 240 miles divided by 60 miles per hour, right? You go down the hill faster. You go down the hill faster, so not a surprise. It takes you less time to go down the hill, so it would take you 4 hours to go down the hill, right? And it seems like a lot of work. There's different ways to do this, but most of this work is being done to get us to figure out what work to do. So now look, now we're almost there. Apparently, I now have all the facts to plug in, right? Under my hypothesis of making up that a hill is 240 miles high, I now say that my total distance is 240 up, 240 down. That's going to be 480. And I now have timings. I take 4 hours. I take 6 hours to go up, and then I take 4 hours to come down, right? I take a while to go up, but then I take less time to go down because I'm going faster on the way down. In fact, even notice the ratio. Doesn't it sort of make sense? Here's a little foreshadow. It took me 6 hours to go up. It takes me 4 hours to come down. In other words, it took me about it took me exactly 2/3 the amount of time to come down than it did to go up because I was only going 2/3 as fast on the way up, on the way down. Not a coincidence. Totally makes sense, right? Now, but what does this do for me? Well, now I have all my facts. Under this hypothesis, I have all my facts. So I say that the average speed for the whole thing, so x up plus x down, because we're doing the whole thing, right, is t up plus t down. So we get 240 plus 240 miles over over 4 plus 6 hours, right? So I get 480 miles over 10 hours. So I get 48 miles per hour now. Wait, how much? I have 13 minutes left. Okay. This is still PAW4. I get 48. Now, is that the answer? Well, first of all, at least one person, actually exactly one person in the direct chat, I'm very proud of that, very appreciative. Oh, no, sorry, no, more than one person. I'm totally bad. A couple of people as an answer in the chat. One person watched a previous lecture, which I think is awesome. Another person went in a method that she or he says is roundabout, might not have been even more roundabout than mine. But so a couple of people also think this is the answer. I mean, is this the answer? Like, because you might, if you're really with me right now, and I probably should change the view for a second and see if you're really with me, what you might be saying is, okay, I sort of see what you're doing, wackadoo. I sort of see that that's the answer if you assume that the hill is 240 miles high, but like that's quite like an assumption, like dude, like you didn't prove it at all. You just proved it for your guess. You might be right about that, but I think this is the answer, and I'll tell you why. Well, wait, I'm just looking at the time. I think this is the answer. This is the answer. It is the answer. You know why? Wait. Oh my God. Oh my God. Oh, that's so awesome. All right. So someone just saved us a lot of heartache. So someone in the direct chat and please like screenshot these, remind me later. Like and you know, a lot of these people are in the direct chat because it's still the beginning of the class and they don't want to go out on a limb. And I totally respect that. But hopefully someday these people that are in the, and also because I asked you to be in the direct chat. Good point. Okay. But yeah, someone in the direct chat just literally said the thing that was hoping to do next. Someone in the direct chat said, I used 20 miles for the hill and I got the same answer as well. Whoa, what? Now that's, that's the next test. I mean, that's what I was going to say next is the next thing. If you were to do this in an exam, if you were to put in the placeholder number and then watch what you did, now you have a bunch of options at your disposal. But one option is to say to yourself, if I tried a different number, would I still get the same answer? And you could just try a different number now, like another number that's easy to work with or a number that you like 20. And if you get the same answer again, does that prove it? No, maybe not, but it starts to strongly suggest that something is going on here. And let me say this. Something is and so I'm totally psyched. Someone in the room used 20 and got the same answer. That makes me feel better. It increases my confidence. And secret thing, by the way, does it prove it? No, but it increases my confidence. So what does confidence have to do with anything? It has to do with everything, because especially if this were an exam, the thing that's going to make, and in this whole science program that you're in, the whole thing that makes the difference is the confidence to go on. Because I'll tell you one, no, don't get me started. I'm about to get started, but I've said this before and I'll say it again. The reason this program that you're in, this science program, is legitimate, why this degree matters, why this degree is worth it, why you're going to get jobs after all your suffering, and you're going to get into graduate school after all your suffering, is because the world knows it's a legitimate program. And how do they know it's a legitimate program? Because some people who start it don't finish it. Scary, but true, right? Same thing with this class. A lot of people will get in it. Yeah, okay. And someone just said, okay, wait, I'm getting myself I only have 9 minutes. Someone just said something in the chat, like, so we just make up the distance. So we just make up the distance and everybody has the final answers with different distances, but that is okay. Very good question. Here's what I'm really trying to get at is you make up the distance to work with at first, but then what you're going to see is by making up the distance, if that gives you the confidence to go forward in the problem. Yeah. Good. What Sarah said in the chat. See, look, and I'm watching the clock. We have 8 minutes. I'm saying to make up a distance because it allows you to progress in the problem. And the whole trick of doing these problems, just like the trick of getting through the science program is to keep going. The people that finish this program finish with a really legitimate degree because some people don't finish. And what's the same thing with this class? Even if a lot of people get an A, every A is legitimate because some people will get an incomplete or an F or a D. And what's the difference between the person that gets the A or the person that gets the F? The person that made it to the end. And what makes you a person who makes it to the end is a person who keeps going in the middle. So what I'm saying is this, in an exam or something, when in doubt, first make up a distance. Yes, just to give you something to keep you going, But once you made up the distance, I want everybody to look like I've got 8 minutes. Yes, I just made up a distance. And yes, somebody else made up a different distance. And the fact that we both got the same answer is a strong suggestion of something. But I can do better than a strong suggestion. I am a scientist. We can be rigorous about this. I'm just saying I've now built up the confidence in myself to be rigorous. I'm going to say this. Wait, so did the distance matter? Here's the question. Did the distance matter? And look back. Like I got 480 over 10, right? And this relates to what Sarah, this totally relates to what Sarah put in the chat. And what everybody's putting in the chat is great. But look back for a second. Where did I get, remember, sorry. Remember here, I have like 240 plus 240 over 4 plus 6. The question is, where did I get that 4 and that 6? Well, look back a previous page. I got the 4 and the 6 by taking 240 divided by 40, or by taking 240 and divided by 60. What I'm really trying to say is, what I'm saying, I use the 240 over here in the numerator of this fraction, but I also used the 240 over here, which ended up being in the denominator of that fraction. I'm saying we made up a distance for the hill of 240, but we ended up using it twice. One place that ended up going in the numerator and one place that ended up going in the denominator. I think it canceled out. I think it didn't matter at all. Right. Exactly. No, that totally what Sarah's writing. I'm now going to write in my language exactly what Sarah's writing, and it may work better for you the way Sarah's putting it. But what I'm really saying is this: if you think what I just did doesn't seem very scientific, I'm saying, yeah, it's a little messy because I'm trying to show you what you do if you were stressed out and you didn't see the science. But here's the real science of it. Here's the cleaned up version. What I'm really saying is, and why algebra was invented and all this is, okay, you don't want to call the hill 240 or you don't want to call it 20 because it seems like a lie. Let's do what real mathematicians and scientists would really do and say, let the hill distance be called X, okay? Like, let's admit we don't know it. Let's give it a placeholder variable name called X, right? If it, and that's legitimate, it's X, right? We're admitting we don't know. If we do that, look what happens. I'm gonna go fast because we have 6 minutes, but look what happens. Then if we just call it X, which is really like calling it 240, it's just making a placeholder for it. But then the average speed for the entire round trip distance, whoops, sorry, is X plus X, right? Like total distance over total time. So it's X plus X over what? Over time up. What was time up? Distance over speed. In other words, X over 40 plus X over 60, right? If you just see previous pages where I got that from, I'm saying, right, because time up, for example, equaled distance up over speed up, right? So I'm going to go, we've got 5 minutes, right? So I'm saying if you want to be strictly scientific about this, if you don't want to guess or make anything up or experiment, but again, I'm saying, like, what is real science? Real science is experimentation. Don't be afraid to play around. But if you don't want to play around and you want to be by the book about it, well, then what I'm saying by the book is that the average speed is X up plus X down over X over 40 plus X over 60. That's what we just did. If you look back at our work, it's just that we called X 240. And if that's what it is, right, then going to the next page, then V average equals 2X, right, over X over 40 plus X over 60. Now that looks really complicated. I mean, it's like fractions within fractions. But you know, we can simplify that. We can factor out an X in the bottom, right? And say, okay, fine, I'm going to factor out an X and say X over 1 over 40 plus 1 over 60. All of this, honestly, is just the algebraic way of saying what Sarah put in the chat. And also what Euban and, what various direct people put in the chat, but specifically what Sarah's putting in the chat, totally right. And this is just an algebraic way of saying it. I'm saying, really, what we're saying is it's the total distance over the total time, and each time is a distance over a speed. So the unknown factor X, I just factored out from the bottom. It's on the top. So now you know I can literally, I mean, you know, X over 7 over 7 is 1. 14 over 14 is 1. X over X is 1. You know, anything divided by itself is 1, right? So I can literally cancel out the X's. And what V literally is 2 over 1/40th plus 1/60th. It literally, like, the distance of the hill doesn't matter. It's all about the ratios. It's about the fact, like Sarah said, that you go up the hill at 2/3 the speed that you go down the hill. So you're going to take 3/2 the time to go up as down. And so in order to add fractions, you need a common denominator, right? In other words, so now it's back to the 240. So I'll do the 240 again. In other words, like 6 over 240 plus 4 over 2, right? Because I'm just getting common denominators. I'll do this really quickly. We have 2 more minutes. I want to finish with one. We're just about finished, but so I get that V bar equals 2 over 6, 2, which not coincidentally looks like the numbers I had before, not coincident. So 2 over 10 over 240. And to divide by a fraction, you multiply by the reciprocal. So you get 480. Well, hello. 480 over 10. And so literally without making up anything, we get 48 miles per hour. And that is total. And so that's my final answer circled. That is the answer. And let me say, with 1 minute left of class, here's the real deal. That is really the answer because it's right. And also the nature of that right answer shows why the wrong answer is wrong. Because here's what this is really saying. To go all the way back to, like, well, why wasn't my method right? Like, why couldn't I just average 40 and 50? Because average speed, because average speed means per time. So the fact of the matter is, if you went up a certain hill, and I'm watching the clock, I have 1 minute, just bear with me, and then we'll be done. If you go up a hill and then you come down a hill, the same hill, we spent more time going up the hill than we did going down the hill. So we spent more time going 40 miles per hour than we did going 60 miles per hour. So what this is really like saying, with 30 seconds left, please, is yes, if you took 2 exams in this class and you got a 40 on one and a 60 on the other, sure, your average would be a 50. But this situation is not equivalent to that. This situation is like, if you have a good day, this situation is like if you got 3 40s on tests and 2 60s. That's what this is like. You got a 40 and a 40 and a 40 and a 60 and a 60. We have 3 times as much 40s versus 2 times as many 60s. So the average speed is closer to 40 than it is to 60. The average speed is a little bit less than 50 because we spent more of our time going the slow speed. So the average speed is a little slower than 50. It actually makes total sense even when you do think about averages. It is an average. It's just not straight up 40 plus 60. Okay. Yes. Have a great day, everybody. Sorry it took so long. I'll stay for questions. Yes. Thank you. Have a great, and thank you for saying goodbye when you, but I hope that makes sense. That's the answer. Okay. Have a great week. You've been very, have a great, yes. Thank you. Great job, everybody. And great job. Great job. Yes. Have a great week. Have a good, yes, you have a great rest of the day too. Thank you. Have a good day. Yes, have a good day. Thank you.